Here we go. So on your exponential function models assignment, your 3.1 assignment, A and B, we're going to start off with here. It says express the function f of t equals e to the 3t in the form of f of t equals b to the t, where b is a constant, okay? So basically, it's saying if you work for a company, you're not going to go to the company and says, oh, guys, we're growing at a e to the third power. No, you're not going to tell them that. You're going to give them an actual value of what they're growing at, right? An actual numerical value. And what we're going to do is go through how to find that numerical value from the point where we're at, okay? So it says f of t e to the 3t, okay? So it says f of t equals e to the 3t. I'm so sorry for how tiny your papers turned out. I was trying to be a tree saver, and it was like 4 papers that they wanted me to give each student. And I was like, you know what? I can turn this into 1 paper. And I didn't realize how small it was until all the copies were made. So my bad, bros. All right, but it's strengthening your eyes. We're doing some eye exercise. I didn't want to have to staple. I didn't want to staple, okay? All right, here we go. Now, the key thing here is when we did our e to the 4x power and we multiplied, right? We used our power rule. This is the example of a completed power rule. Does that make sense? I multiplied 2 powers together, correct? So if I multiply 2 powers together, I can separate them. Okay? I can separate them. So this can separate to become e to the 3rd and to the t, right? Because that's how the power rule works. That's how 3 to the t came, because I multiplied t times 3. Does that make sense? Yeah. So now, I now have my base. This is now my b. So I now know that b is e to the 3rd. And I can use a calculator to find an approximate value to tell my team what our growth looks like or our decay looks like now, right? So I would just go to the calculator and I'm going to type in e to the 3rd. To get your e, you're pressing second natural log. On your calculator, it's going to look like a lowercase l and a lowercase n. On mine, they're capital letters. It's a lowercase l. But once you press it, you're going to get this little e. Did we all get the little e? Yeah. All right, so second natural log. Okay, so I have e to the 3rd. I get a numerical value now, right? So I have a constant. So e to the 3rd, notice how we wrote approximately second ln. It looks a lowercase l and a lowercase n. And we're going to round to the nearest 3 decimal places. So we have 20 and 86 thousandths. Can we see that? Okay, that is my value. Now that I have my factor, is it a growth factor or a decay factor? Why is it a growth factor? Not because it's positive, because it's what? Bigger than 1. It is greater than 1. So therefore, this is a growth. Got it? All right, so that is what you're doing for 2 and 3. Okay, we're going to let you come back to that. We need to do one more together. Yep, so we're doing 4 together. All right, on 4, we're reviewing our transformation rules. Okay, so we have, it says g of x equals e to the x plus 5. And it wants us to describe the transformation and then create a step to separate our variable from our constant, right? All right, what transformation took place here? Good job, because our x's are what? Liars. So we translate 5 left. Agree? That's our transformation that took place. That's part 1 that it wants to identify, is what is your transformation? After you identify the transformation, it wants you to separate your variable and your constant. Okay? When we think about Yes, good job, Rebecca. All right, so when we think about exponents, at what point do you add your powers? When you're multiplying them and they have the same base. So what Annabeth said is that this would be e to the x times e to the 5th, because that's when I would end up, bless you, multiplying them. And now, can I calculate what my a value is? Bless you.
Separated.
Okay, and so I can now approximate my a value because I have e to the 5. And can I put e to the 5 in the calculator and get an approximate value? Yes. Okay, and a represents our what? What do we say that a is? A is our what? It plays 2 roles. It's either our, wrote it down in our notes yesterday. You can always look at your notes. Not
It's either
our stretch, compression,
or reflection.
or our reflection, right? Depending on its value, it's either our stretch, our compression, or our reflection, right? All right, so what do we get for A? 148 what? 413. So A is greater than 1. So it's a stretch. Good job. So therefore, this is a stretch. So it's going to cause our graph to stretch. All right.